Okay, this is the graphing exponential functions video. Thank you for tuning in. We're going to learn all about how to graph an exponential function. Okay, so for the very first example, we're going to learn how to graph y equals 2 times 3 to the x. In order to do this, I suggest you make an x and y table. Okay, so the very first thing that you should note is that this is a growth function because our b is greater than 1. 3 is our b. Okay, and so we're going to use that as our guide to kind of help us see that our graph is going to have a general shape of this. Okay, and this is also our y-intercept. And so I should know that I want to write 0, 2 as my first thing. And I always like to put that in the middle just because it's nice to see. So we'll go ahead and plot that 0, 2 right here on the graph. Okay? Then we're going to go back 1 to negative 1. And to do that, you just plug in negative 1 for x. And 3 to the negative 1 power, if you remember our exponent rules, means to write 3 on the bottom or in the denominator, or it becomes 1/3. And 2 times 1/3 is 2/3. Okay, so we'll plot that on our graph. Now 2/3 is slightly less than 1. It's a third, 2/3 of the way up to 1, so it's going to be here. It's about 0.666666666 repeating. Okay, so that's where it would go. Then we'll plug in negative 2, and when you plug in negative 2, you get 3 to square on the bottom, which is 2 to the 9th. And so we'll go ahead and plot that on the graph. Now 2/9 is really like 0.22222 repeating, and that's getting closer and closer to that 0 line. And we'll shimmy a negative 3 in that little space I provided myself. And then that gives you 2 times 3 to the negative 3. And 3 to the negative 3 really means the 3 to the third on the bottom. And you get 2 to the 27th. 2 over 27. And that's really, really close to 0. Okay, but it's not on 0. Okay, and you'll notice that it gets really, really close to 0, and it'll keep getting really close to 0, but it will actually never touch 0. Okay, so now let's go to the other way. Looking like we're getting too little room to start writing in numbers. So we'll plug in a 1, and so you get 2 times 3 to the first, which is really 2 times 3, which is 6. So we'll plot that on there. And then we'll plug in 2 for x, so you get 2 times 3 squared. Well, 3 squared is 9. 2 times 9 is 18. And you'll see that we have definitely no room to write 18 on there. And now we'll connect our dots. And you'll get this general shape, which is like the shape that we predicted in the beginning. Okay? And some key features that you need to notice is that we get our line will come right up against the 0 line, but it'll actually never touch. If we zoomed in right here, there would be a gap between the red line and the black line right here. Okay? And then notice how it starts out kind of slowly coming up, and then all of a sudden it just shoots off like a rocket. That's because our growth factor is a 3, and that's pretty big when it comes in terms of exponential growth. It'll start to go up pretty steeply, pretty quickly when you have something in a growth factor of 3 range. Okay? So now, what we call this thing when it gets really close to something, but it'll never, ever, ever hit, is called an asymptote. Okay? All exponential functions that we do will have an asymptote. Okay? And most of the time it's supposed to be around 0, because as you get smaller with the exponents here, it'll get really close to 0. It'll make the numbers really big on bottom, but it'll never make it get to where it can be 0. There will always be a number there, always some fraction that'll make it smaller and smaller and smaller as you get there. And while it may not look any different when we draw the graph this way, it actually is getting closer and closer to 0, just not touching it. Okay? And so that's called an asymptote. Now, let's talk about our domain and range. So our domain of the function talks about the x, like all the possible x values this could be, or how far to the left will it go and how far right will it go. Well, you draw these arrows on the end because it lets you know that the graph keeps going. So if you look, this graph keeps going in this direction, and it'll go that way forever. So that's why this is negative infinity. And then we'll go to the right. While it looks like it peaks out right here, if we could zoom out enough, this graph will also continue going to the right forever and ever and ever. That's why it's positive infinity. Okay? Now the range talks about the y values. Okay? So we just talked about this asymptote. Our red line will never go below y equals 0. It actually never hit y equals 0. Okay? So we're going to go to 0, and it's not really going to include 0 all the way to infinity. Like it'll just go up and up and up and up. Okay? So that's why our range is negative, our domain is negative infinity to positive infinity, and our range goes from that asymptote on up. Okay? So now let's take a look at a different graph. Your example number 2, f of x equals 6 times 1/2 to the x. Okay? Well, right out the gate, you should see that this is going to be a decay function, because if we look here, that's going to be less than 1, so we're going to have a decay graph. And then we look, and what's our y-intercept? 0, 6, because of that 6 right in front. So let's go ahead and plot that. And then we're going to go up to I guess we'll go back to -1. And when you plug in -1, remember, plugging in a negative means you're going to flip your fraction. Whatever's on the bottom goes to the top, and vice versa. And so it becomes 6 times 2 over 1, which is 12. We go to try to plot that, and it goes off our graph a little bit. Kind of shimmy it in there. Okay? And then if you plot 24, -2, that'll give you 24. And it goes way, way up. We can't fit that on the graph. And then if you will plot 1, when you plug in 1, you get 6 times 1/2, which is 3. And so we'll plot that there. And what you'll start to see is the pattern in the table. I didn't address it in the first one. I should have. We'll go back to the other table real quick. If you'll look at the pattern in the table, you should see our growth factor in here. So you have 2 to the 27th, then it goes 2 to the 9th, 2 to the 3rd, 2, 6, 18, and so you'll start to see that multiplying by 3 more right here than you would in the other ones, because you'll need to know that when you multiply by 3, the denominator actually reduces by 3 each time. So each of these is technically being multiplied by 3 to go from one to the next. And so that's that growth factor that we see here. And then 2 is our y-intercept right there. Okay? And so let's go back to where we were in our graph. Okay? And you'll see our pattern dividing by 2, or the way we'll write this, because we always have to write it using multiplication, is 1/2. So we're multiplying by half. So half of 12 is 6. Half of 6 is 3. Half of 3, this is where you start getting into fractional notation. 3 times 1 over 2, which is 3 over 2. Okay? And then you'll see that you get 3/4. Let's go ahead and plot that on there. And you should start to see that that's really like multiplying by 2 to the denominator. So we're going to go ahead and just put 3/8 because you just multiplied the denominator by 2. And we'll plot that point. And then let's just keep going. You get 3/16, and you'll see that the line starts out really steep and then comes down and gradually comes closer and closer and closer to 0, creating that line right there. And it's kind of like the flip-flop of the other equation that we did. And you'll notice that it's really steep in the beginning, and then it starts to level off. But what does it never hit? That 0. That's still our asymptote right there. Okay? Now, the domain, it goes from negative infinity all the way to positive infinity. Its range goes from 0 to infinity. Okay? And that's it, guys. That's how you graph an exponential function. Just plug in numbers and solve it out. Now, you could use your calculator, plug it into y equals, and solve it out. Go to your table, use those to plot the exact values, or use the graph to check and see if you have the correct directions and all those things. Okay, thank you for watching this video.